So calculating velocity, how fast something's moving. First off, velocity is a vector, just to let you guys know. Sometimes you'll see calculating speed, which is a scalar. So as I already talked about the differences between scalar and vector and velocity and speed and distance and displacement. Don't worry about that. They're very interchangeably. There are definitely differences, but in general, I'm not going to sit here and try to trick you between that. So the equation we're looking for is velocity is equal to your distance, or since this is velocity, change in position, which is called displacement, remember? So if we're calculating velocity, we're going to need to know the change in displacement, or change in position, so displacement, and then divided by time. Now, how much time has changed? Now, sometimes you'll see it written as delta t, or just t. It's the same thing. Normally, they're just going to tell you the t, how much time it took. But what if they told you the dog started at time equals 25, and then when they'll say that's the initial time, and then the time final is 75 seconds. So it started when the time was 25 seconds and it ended at 75 seconds. Well, that's 50 seconds, right? This is the final. That's an F right there, by the way. So this is the final time, and it started at this time. So it didn't start when time was 0. So that's why they put change in time, because how much did the time change during that time? Most of the time we just take this number and we stick it right in there. So most of the time you'll just see it like this. This is the exact same thing. Okay. So you'll just see that, and you can just stick that time in there. It's fine. Rarely, unless you're taking some really more advanced math classes, do they start introducing that, because it's kind of a dumb abstract thing. I mean, it's almost common sense, but there are times in physics where, things don't start exactly when the clock starts, right? So, but most of the time we're not going to worry about that in this class, this summer school class. We'll just kind of give you how much time it took for something to happen, and we'll just stick it in there, okay? So the first step one in this class is we should always look at what data are we given. I see numbers, then that's data. Sometimes data actually doesn't even have a number to it, and you'll see that later. Like it says, until the dog stops. Oh, the dog ends up stopping, so the dog's final speed is 0. Okay, so it doesn't have to give a number. Okay, but if you see a number, definitely that's data. So, okay, here's some information I need, and here's some more information I need, or I might be able to use, correct? So, obviously, this one's a distance or a displacement. So, in this class, we should always just assume it's a displacement or something, but you can read into the question and read, and it walks 200 meters. Okay, so I'm assuming it's going to be in a straight line or something like that. So, 200 meters, and that's my displacement. And then the time. That's the other thing. What are seconds? If you see seconds, minutes, or hours, that's time. If you see meters, miles, inches, feet, that's distance, right? So this is 50 seconds right here. And then we got to figure out, is there any other information that they're asking for? That's step 2. So step one is write down. Step 1, write given info. Step 2, what are they looking for? So there's always going to be a variable we don't know. I mean, this is physics, right? So there's always going to be something we know. How fast is the dog walking? So how fast? They might say, what is the speed? What is the velocity? How fast is it going? What was the rate of the motion? I mean, those all mean the same thing. And they're all looking for a velocity or a speed or something like that, which, like I said, are kind of interchangeable. There's like distinct differences between being scalar and vector, but they're in the same boat. So they're definitely looking for this, okay? At this point, if it's a constant velocity problem or an average velocity problem, then we could just use a very simple equation like this, okay? When you see the thing, when they're not talking about the thing speeding up or changing speeds and all that stuff and getting complex, and it's just talking about distance and time, we can just use a simple equation like that. So that's step 3. Find an equation. Find equation that fits. In other words, that fits the stuff we have and don't know. So here's information I have, I don't know. Let's find the equation. We got it right there. So let's So then let's move on to this. I already found the right equation. It's right there. Step 4. I don't know. Plug in and solve. Plug and solve. That's it. So let's plug everything in. V equals, well, I don't know V, so I'm just going to put V. And then equals 200 meters. That's the X on the top, right? And then 50 seconds, that's the time. And then I take 200 divided by 50 in my calculator, and you get 4. And then look at this unit and this unit. It's that unit divided by that unit. So I'm going to put that unit divided by that unit. 4 meters per second. So here's my answer. And that's pretty much it. That's how you pretty much solve anything that's moving along and it's not complex. In other words, there's no speeding up, no changing speeds, no final and starting speeds. It's literally just some distance that something travels in some time, and that's it. Okay? So that's it, guys.